Okay. Okay, we are on number 3. In fact, I don't think we have too much more left in this review packet. I think we got a probability problem coming up. Truth tables, do you guys remember those? Those are fun. Okay. All right, so this one here, a bank clerk is offered a yearly salary of 18,000 Swiss francs for the first year of employment. She's also to receive 500 francs a year increase at the beginning of each subsequent year. So A, what is her salary at the beginning of the 5th year? Okay, so really when it comes down to it, this is just a sequence problem, right? Okay. Hold out, this one won't be a sum. We just want to know what's her salary at the beginning of the 5th year. We don't want to know how much she's made throughout the years. So does anybody remember what that explicit version is? Yes, sir.
I know the answer, but I forgot the name of the version.
Okay, well, do you have the answer for the first?
Yeah.
What would it be?
20,000.
It is 20,000. Okay. She's going to end up with 20,000 Swiss francs. Okay, so let's see how John was able to get that. Well, the formula, if you want to find the nth term of an arithmetic sequence, you took the first term and added, does anybody remember? N minus 1 times what? The common difference. There we go. That value that you were adding over and over again, or subtracting, depending on the sum. So she started the salary or very first year with 18,000. So that is the first term. Okay. And then the common difference is going to be 500 because beginning of the second year and the third year, we're just going to continue to add 500 onto that. So what's the value of n for question A? N would equal 5 because we're interested in knowing the sum at the beginning of the 5th year. So A sub 5 equals the first term, 18,000, plus, okay, so if I go ahead and plug in 5 there, I'm going to take 4 and multiply it by the common difference of 500. So 18,000 plus 2,000, there's the 20,000 francs. Or Swiss francs, I'm sorry. Okay. All right, good. Now the second part here, it says after the first 5 years, she's to receive a yearly increase of 750 francs until she reaches a maximum annual salary of 26,000. Okay, what's her salary at the beginning of the 6th year? Well, this was the beginning of the 5th, so the 6th would be 20,750, correct? Okay. All right. So at the beginning of which year of her employment does her salary reach the maximum? So we're looking for the number of years. Now, basically we have 2 sequences here. The first 5 we are increasing by 500 each time, but from 6 on until I reach this cap, we are going to go ahead and increase by 750 per year. So let's pretend that the other portion doesn't exist for right now. Let's go ahead and say that the first term is 20,750. We're going to use this guy again. So A sub n is equal to A sub 1 plus n minus 1 times d. Okay, well, we know d is equal to the 750. Okay, we know the first term now is going to be the 20,750 francs. Okay, and we know that it's going to cap out at what? 26,000. So once she reaches 26,000 a year, she's not going to be getting any more money in addition to that, right? So what am I actually trying to solve for in the formula? Okay, what's that? N. We're trying to find the number of years. So I'm going to go ahead and say that the 26,000, the most she's going to be able to get, equals the first term 20,750, okay, plus n minus 1 times 750. Okay. And now we just need to do a little bit of algebra, but has anybody already solved it? I'm sorry? 2? No, a little higher. Let's take a look. So I got 26,000 equals the 20,750. Let's go ahead and distribute. So that would be 750n minus 750. Okay. So this right here, the 20,750 minus the 750, that's just going to give me 20,000. But then I'm going to go ahead and subtract that over. What do I have over here? 6,000, right? Equals the 750 in. So how many years until she reaches that 26,000? Okay, not 12, not 14.
Well,
We're really close.
adding the first-
Now here's the thing. N equals what? 8, right?
Yeah.
Okay, but now we're going to add on the previous 5 years because this started with her 6th year. Okay, so the 8 plus 5 would actually give me 13. Because remember, this problem was made up of 2 different sequences. The first 5, she was increasing by 500 francs per year, and then when she gets to the 6th year, then it starts increasing by 750 per year. So we're really close. We had 12 and 14, I think you said? Yeah. Luis. Oh, yeah. Okay. Now, I'll go ahead and do whatever you guys think is best. As of Monday, we will be exactly 3 weeks away from your first test. So my plan was to go ahead, just kind of devote all these class periods to these reviews, kind of go through them one by one. What do you think is going to be most beneficial to you? Would you like to come on up and work more of these problems? Do you want me to continue the lecture style? Cindy? Just make a list. I could probably come up with a list of all the topics. Okay. All right. Anything else? Hey. Okay. Did you want to start that on Monday then? Because you have review 2, and I hate to, give you anything to do over the long weekend, Easter weekend. You're probably going to spend time with your families, but the time is running out. I do encourage you to go ahead and take a little bit of time to try some of these problems here. So absolutely. How about, do you want Monday, the entire class period, to work on that second review, and then we start on Tuesday? Okay, that'll work. We can do that if you want to. Absolutely. All right, so if you have any ideas, let me know, because I want to make sure that everything works out and we do everything we need to. All right. Would you like to try one? Okay. Well, like this one here, would you like to try it on your own? How many people remember truth tables? Okay. So good. Okay. All right. Well, let me go ahead and at least let you get started. How about, I'm showing 146. What do you think? 5 minutes? Is that enough? You think more? Alejandro, what do you think? A little bit more? 7 minutes? Well, these questions here, that's how I determine the amount of time to give you on the exit ticket. If those questions had appeared on exam 1, you've got 15 questions, but 90 minutes. So I'm thinking about 6 minutes each. That's how I came up with the 12. So, it's going to be different on the second exam because you only have 6 questions. So you'll have a little more. And not every question, I would think, is going to take 6 minutes. Some of these could go quickly. Some of these are definitely going to take longer than 6 minutes. Also, depending on strategies you use. So I think 7 minutes probably sounds pretty good. Okay. So let me go ahead and set a timer. I think I got the timer right here. Okay. All right. Okay, so if you happen to have your notes from the first semester when we did this, I want to say it was second 6 weeks. It goes back pretty far. If you don't remember, get with somebody. You got your billing buddies around you. Okay. Whatever we need to do. Okay, so we'll come back together in 6.5 minutes. There should be some over there still. Okay. All right. Actually, I don't know if turning that off will stop the recording or not. We're going to see. All right. All right. John, if you turn on that light for me, sir. I believe it should. those up there. Okay, I'm screwed. And if you haven't already seen, I have posted the answers to review 1. I'll probably go ahead and post review 2 later next week, and then I'll just keep going as we progress. Anybody else need the homework key for today? Joe? I also printed off review 3 today. I've got 6 total. Would you like me to go ahead and pass that out, or do you feel you have enough right now? You want another one? Okay. More math is always a good thing. No, this is just a review of the different concepts throughout the year. So the next release test I'm going to be giving you is the 2018 version. Yeah, different resources. Mm-hmm. Okay. So this is the 3rd review. I think I gave you 3. One for Louise. Yes, let me go get that real fast. Okay. Hey, Louise, right now we're working on number 4 in review 1. I believe Jocelyn has the key right now. There you go. Hey.
How would you write that with the arrows?
Now that wouldn't be an arrow. It would be a quantity. In fact, you're comparing 2 quantities with the implication. So what you have to decide on that particular one, is it going to be inclusive or exclusive? And then you go ahead and make a larger statement based on those. Because you'll notice in the paragraph, the first 2 sentences are those that you did there. Mm-hmm. You're close. We just need to connect these somehow. Like the implication to that or to the not. Oh, and I haven't mentioned it yet. Don't forget what's tomorrow. Okay, that's the exam. Think of it as a big quiz. Okay, but that's going to cover derivatives. Okay, you'll have the difference quotient on there, limits, tangent lines, all that good stuff. Do, 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 do. Is that the key? Thank you.
I did have a quick clip of it.
Okay. Okay, and that was 7 minutes. Okay, so let's see how far we can get before '09 hits. John, if you turn off that light for me again, sir. Okay, so we're on truth tables for number 4. It says the propositions P, Q, and R are defined as follows. This is a good course. The course is worth taking, and the grading is lenient. Okay, so A, write a symbolic statement for each of the following sentences. If this is a good course, then it is worth taking. Okay, well, what stands out to you from that sentence? The if-then. Remember, that's an implication. So how would I show that symbolically, if I can talk today? With an arrow. There we go. So this is proposition P. This one is Q. So I would go ahead and say P implies Q. Those are your if-then statements. Okay. Then it says either the grading is lenient or the course is not worth taking. Okay. Well, the key word I would see here is what? Okay, or, and as I was talking to Spencer about, you have to decide, would this be the inclusive or the exclusive? And what was the difference? Okay, so that one was the what? That's the inclusive. Now, we know it's exclusive if there is a line underneath it. That's the exclusive. Okay. Okay, so the inclusive is one or the other or both, but the exclusive is one or the other, but not both. So what would we do here? I would do exclusive. Okay, because it doesn't make sense for it to both be lenient and not worth taking. Does that make sense? But there's also something else there. Okay, well, it's not the either, the not. There we go. So the grading is lenient, that's R. The course is not worth taking. Now that's Q. So what I would do is say R exclusive union. And how do we show not? Okay, it looks like the sideways L. Okay. Now remember, it can also show up on the exam, you know, as a little tilde symbol. Okay. Like similarity. Okay. So if it does, don't worry about that. All right, now write the following argument using P, Q, R, and logic symbols or connectives only. Okay, well, you'll notice if this is a good course, then it's worth taking. Either the grading is lenient or the course is not worth taking. Those are the first 2 statements that you went ahead and took care of. So I'm going to start by showing the implication. So P implies Q. And now we have either the grading is lenient or the course is not worth taking. So R exclusive. Okay. Not Q. Now it goes on to say, but the grading is not lenient. Okay, so I'm going to go ahead and say not R. Now here's the thing about this. These 3 propositions are true. So what we're saying is that these 3 statements are going to imply our conclusion. So because we have the implication overall to this last statement here, therefore this is not a good course, I'm going to connect them with and. This and this and this will imply my conclusion. Okay, so I'm going to go ahead and put all that in brackets. Therefore, this is not a good course, so I would go ahead and say not P.
Do we need to put parentheses around the separate statements?
That would probably be a good idea, just to go ahead and further, isolate those. There we go. Okay. How many people got that symbol expression correct? Okay. Probably the one thing that's the hardest on the truth tables is creating those. But again, you're going to see this a lot as we go through these review problems. Like they had you set up 1 and 2 in preparation for what was coming. So a lot of times, especially on that second exam with those multi-step questions, you're going to be finding specific answers and then doing something with that later on. Okay. Okay, so let's go ahead and create the truth table to go ahead and see if we have, what kind of argument we have. Does anybody remember, what if we get nothing but falses? That's a contradiction. What if we get nothing but truths? That's a tautology. Tautology, there we go. All right, so you'll notice what I did because this really didn't have enough room for like this entire expression right here. So when we first did this back in the second 6 weeks, we always started with the smallest parts and then we started to build our way up. Like one part of this would be P implies Q, and that's what I'm going to say 1 is. So this column 1 right here is just P implies Q. And then the second one here would be the other argument here. So I would go ahead and say R exclusive, not Q. Okay. And then for 3, that's when I took the union of those two. Okay. And I just kept going like that. So let me see. This would be P implies Q and R exclusive, not Q. Okay. And then what do you think 4 is? Okay. 4 is this. Okay. So I want to take the intersection of that and not R, and then 5 would be the implication to get the conclusion that the class is not a good course. Okay. So that's what I did. I just numbered over to the side because, yeah, there was no way you're going to fit that within that small little column right there. But do you guys remember, does it make sense why we have 8 rows? You remember the base we used to tell? Half and half? Like, how do you mean? Yeah, now whatever you have, like, for example, if there's only 4 rows, then it goes true, true, false, false. And then you alternate. You remember we had base 2, and you always raised it to the power of the number of propositions you have? So 2 cubed is what gave me the 8? Does that sound familiar? Yeah. Okay. No? I said, oh, well, I don't think you were in here at that point. Yeah. Okay. So what you do is you take 2 and you raise it to the number of propositions. That tells you how many rows you're going to have. So for example, if I only had 2 propositions, P and Q, then my table would only have 4 rows, 2 squared. Okay. Now before we go ahead and get into this right here, let's go ahead and review some of these, okay, to make sure we remember what's going on. Okay. So, oops, kind of erase this one. Let's do P and Q. So I'm going to go true, true, true. Whoop, yeah, if I can write it. True, true, false, false, and then true, false, true, false. Okay. So what was the intersection? How was I going to get a true statement there? Okay, if they're both true, one and the other. But what if only one is true? Then that's false. So this right here should be true, false, false, false. Okay, so this one here would be true, true, false, false, true, false, true, false. Let me just go ahead and fill in the rest of these. True, true, false, false. Then we have true, false, true, false. And then for this one right here, I think I was going to do the implication. P implies Q, yes. So true, true, false, false, true, false, true, false. Okay, so what was it with the inclusive union? You said it was one or the other or both. So as long as one had a truth, it was good. So what should this column be? True, 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 false. Okay, for inclusive, only one of them has to be true in order to get a true statement. Okay, Alejandro, what was exclusive again? One or the other, but not both. So what would this last column be here? With exclusive, can I have 2 truths? That's false. What about 1 truth? That's true. One or the other, just not both. And then what about this last one? False. Okay. Now, I'm reasonably sure that your formula book is going to have a table already created for you that has these patterns, but I mean, it's good to be comfortable with it. Does anybody remember the implication? There was only one time you were going to get false. Only if it was true, false. That is exactly right. Every other combination, true, true, false, false, always gave you a true. Okay. And I went ahead and left this last one here. What is it when the arrow goes both ways? That started with an E. That's equivalence. Okay. Oh, sure, I took the picture. I was getting all ready to do it. Okay. Would have made that phone very valuable. Okay. Anyways, what you would have to do is do if P then Q, if Q then P, and then go off of that. So I just went ahead and gave you the pattern there. So two trues, true, true, false, 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 true, false, and false, false, true. Okay. All right. And then, of course, not just changes it from true to false or vice versa. Okay. All right. So let's see here, 204. Oh, I was hoping to get further than this. But let's at least go ahead and get these three columns here. Has everybody had a chance to copy that? Okay, we're good? Or take a picture of it? Okay. All right. So not P just changes what we have here. So this column should be false, 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 true, 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 true. Okay. What would Q be? So false, false, true, true, false, false, true, true. And then not R? Okay. False, true, false, true, false, true, false, true. Okay, that's easy enough. Now we're going to go ahead and start building up to our actual statement here, okay, to see if it's true or if it's completely false. Or maybe there could be aspects of it when it is true or in times when it's false. So let's see, 1. So we're going to start here. P implies Q. So I'm only going to be looking at these two columns. Okay, so I want to show implication. Now remember, order was very important. So we just looked at this. What was the only time we had to worry about it being false? True, false. So as I go through here, I see true, 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 false. So there should be a false right there. True, false. So there's a false right there. False, true. Is that going to work? Yes. And remember, order matters. So it has to be true, false, not false, true. And the rest of those should be okay. So I'm going to go ahead and put truths for the rest of these. Okay. Everybody's okay with that? Okay. Now in 2, we're looking at the exclusive union. Okay. So this is going to compare R and not Q. Okay, so now I'm looking at these two columns. Okay. So it's one or the other, but not both. But not both. So the only time I need to really worry is if each of these two columns has a what? Okay, so let's see. I'm going down. I see a true, true. So I'm going to go ahead and put false. Okay. I see another true, true here, so I'm going to put false. So unless I'm missing any, that's all I'm saying. Did I make a mistake? Yes. Oh, I'm just worried about that one case. Yeah, you're right. Okay. And then do we have two falses? We got one here. We have another one right here. Okay. And that's all I'm saying. So the rest of those should be truths, right? True, 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 true. Okay. All right, I've got 207. Oh, we got farther than I thought we would, but I'll tell you what, we'll go ahead and at least finish up this one problem on Monday, and then I'll give you the rest of the period to go ahead, look at these, look at the second review, and then we'll pick up on Tuesday. Okay. All right. Yes. The exam is just over the calculus unit. Derivatives, limits, tangent lines. Okay.